Our learning target for today, what you guys will be tested on, is I can prove that two lines are parallel using angle theorems. So let's go ahead and get started. First off, we have this question here. Go ahead and pause the video if you'd like and try this one out. This is our warm-up for today. Given line A is parallel to line B, you want to find the measure of angle 1. So we want to find out what this whole angle is. So to do this one, first off, I notice that this angle here, x squared plus 20x, is a corresponding angle with this other angle here, 4x plus 36. And if we recall our angle properties, the relationship between these two angles, they're corresponding angles, and corresponding angles are always congruent. So therefore I can start by setting this up as x squared plus 20x is equal to 4x plus 36. Because if these two angles are congruent, then I can set them equal to each other. From here, I go ahead and I factor this out, so I need to get it in standard form first. So to do that, I move everything over to one side. So I have x squared plus 16x minus 36 equals 0. Now at this point, now that we're in standard form, I can go ahead and I can take my a value, which is 1. I can multiply it by my c value, which is negative 36. So 1 times negative 36 will give us negative 36. And now we want to find numbers that will add to be that middle term, 16, and will multiply to be negative 36. So I start listing all the numbers that will multiply to be negative 36. I have 1 and negative 36. I have 2 and negative 18. I have 6 and negative 6. I have 4 and negative 9. And then I can do the opposites of these, negative 1 and positive 36. Negative 2 and positive 18, negative 4 and positive 9. Now, out of all of these, the only pair that will add to be positive 16 and multiply to be negative 36 is positive 18 and negative 2. So these are the terms that we're looking for here. Negative 2 and positive 18. So at this point, I go ahead and I make my double parentheses. It's the opposite of distributing, so that's why we're taking it apart now. We're making it so that we're seeing two values being multiplied together. And the first thing that goes in both of these is the variable that we're working with, which is x. The second thing is the numbers that we found, negative 2 and positive 18. So I have x minus 2 and x plus 18. Now, these are our two factorizations. At this point, we want to go ahead and give an equation to both of these. So if it has its own parentheses, it gets its own equation. So I have x minus 2 equals 0, and I also have x plus 18 equals 0. Well, solving for both of these, we get x is equal to negative 18 and x is equal to positive 2. So these are two of our values of x. Now, from here, we got to determine what's going to happen if we plug in these numbers. Well, what happens if I plug negative 18 in for x in this angle? Well, 4 times negative 18, well, if we did that, we would get a negative number. So let's go ahead and do that real quick. 4 times 18, 4 times negative 18, will give me negative 72, plus 36 will give me negative 36. So if I use x is equal to negative 18, this would be negative 36 degrees. And I know that's not going to be a negative angle. So therefore, x equals negative 18, that is out. We cannot use that. So let me go ahead and get rid of that negative 36. X cannot equal negative 18. So let's go ahead and try positive 2 instead. Let's see if the 2 works. So I plug 2 in. So if x equals 2, then we have 4x plus 36. That turns to 4 times 2 plus 36. And that's just 8 plus 36, which is 44. So if x is equal to 2, this is 44 degrees, which is a much more reasonable angle rather than seeing a negative 36 degrees. So again, if x is equal to negative 18, then 4x plus 36 turns into negative 36 degrees. So obviously this is out. We cannot use this. So therefore, we know that this angle is 44, this angle would be 44, and we know vertical angles are congruent, so this angle down here is 44. I also know that this 44 degrees here, and the angle right next to it, part of it that creates angle 1, these are supplementary angles because they're a linear pair of angles that create a straight line. So I can do 44 plus x, well, let me change the variable, plus y, this is going to be y for now, is equal to 180 degrees. Well, when we subtract 44 from 180, we're left with 136 degrees. So y is equal to 136. Therefore, angle 1 is equal to 136 plus 44, which of course is a straight angle. So therefore, we can find out that angle 1 is equal to 180 degrees. We know that x is equal to positive 2. These angles are 44 degrees each, and this problem is now complete. All right, so let's go ahead and move on and get into the meat of our notes for today. So first off, this is very important for us. Today we're going to be talking about those angle relationships. So we already know alternate interior, alternate exterior, corresponding, same side interior, and same side exterior. So all of these things we know are true. Now, if we recall, in the past, we needed to know that these were parallel lines before we can see these angle relationships. Today, I'm going to show you guys two angles that are congruent, and we're going to need to determine whether if those two angles are congruent, that will determine if these two lines are parallel. So if I say that angle 3 and angle 6 are congruent to each other, is that enough information to say that these two lines are parallel? Well, yes. Angle 3 and angle 6 are congruent. That means that alternate interior angles are congruent, because again, angle 3 and angle 6's relationship is that they're alternate, meaning opposite sides of my transversal, interior angles inside the parallel lines. So if that's the case, if these two are congruent, that would imply that these lines are parallel. Similarly, if I have this purple angle here, go ahead and use this purple angle, angle 7, and let's also use angle 1. And let's say that these two angles are supplementary. I say angle 1 plus angle 7 equals 180 degrees. Well, looking at these, angle 7 and angle 1 are same side exterior angles. And same side exterior angles are supplementary. That would imply that they are parallel lines. So again, if they're following these angle relationships and these angle relationships match up, they're correct, then that would imply that the lines are parallel. And that's what today's main topic is. We're going to use our angle relationships to determine if the lines are parallel. So we're just working backwards. Now, the last one down here states if two coplanar lines are perpendicular to a third line, that implies parallel lines. So if we have two lines and they're perpendicular to a third line, that implies that these two black lines are parallel to each other. So that's all the sixth statement is saying. If two coplanar lines are perpendicular to a third line, that implies that the lines are parallel. So again, these are all things that we've covered in the past, so make sure that you guys are familiar with these, because you will need to know them regardless. All right, so let's go ahead and practice this a little bit. In each case, state the theorem that proves line A is parallel to line B. So first off, we need to focus on these angle relationships. So what is the angle relationship between these two angles? Well, they're corresponding angles. And if corresponding angles are congruent, that implies that line A will be parallel to line B. The next one, letter B. You have these two angles here. It looks like they're showing that they're congruent. They have the same congruency marks. What's their relationship? Well, they're alternate interior angles. And with alternate interior angles, are those supposed to be supplementary, or congruent? Well, they are supposed to be congruent. Anything alternate will always be congruent. So if these alternate interior angles are congruent, that implies that line A is parallel to line B. So again, we're just trying to find the angle relationship and see if that relationship is true. Lastly, for letter C, we have these two angles here. What is their relationship? Well, they're on alternate sides of our transversal. They're outside of our parallel lines, so therefore they're alternate exterior angles. Are alternate exterior angles supposed to be supplementary or congruent? Well, anything alternate is supposed to be congruent. So these two angles are supposed to be congruent, which they are. Shows it in the congruency marks. So if alternate exterior angles are congruent, that implies line A is parallel to line B. So again, focus on those angle relationships, and you shouldn't have too much of a problem with these. All right, let's go ahead and jump into our first proof of the day. So, problem number 1. Given angle 1 is congruent to angle 2, so these two angles are congruent. Angle PQR is congruent to angle RSP. We want to prove that PQRS is a parallelogram. Now, in order to prove it's a parallelogram is a four-sided figure with both pairs of opposite sides parallel. So I need to prove that QR and PS are parallel, and I also need to prove that QP and RS are parallel as well. So let's go ahead and get started on this, and if you'd like, you can pause it and try this one out on your own, and then we can go through it together as well. So the first thing that they give me is that angle 1 is congruent to angle 2. So I'll go ahead and put that first. Angle 1 is congruent to angle 2. That's given. And I can draw that in my picture. Here's angle 1, here's angle 2. They also tell me that angle PQR is congruent to angle RSP. That's also given. So angle PQR is this full angle here, this blue angle, and angle RSP is also this blue angle down below. We want to prove that PQRS is a parallelogram. So, to do this, first off, what's the relationship between angle 1 and angle 2? Well, looking at this, it seems like I can create parallel lines. I can create these angles here, and we can see that we have two potential parallel lines and a transversal going through. So that's what we're using here. So if this is my transversal, line QS, angle 1 and angle 2's relationship is alternate interior angles. And alternate interior angles need to be congruent. So therefore I can say, for number 3, line PQ is parallel to line RS. So right now I'm saying that these two lines are parallel to each other. And the reason I can say that is because if alternate interior angles are congruent, that implies parallel lines. If alternate interior angles are congruent, that implies parallel lines. Now, next, I have this blue angle here and I have this green angle. If I subtract the green from the blue, wouldn't I be left with angle 3 and angle 4? Well, yes. So from here I can say angle 3 is congruent to angle 4. So number 4, angle 3 is congruent to angle 4. And the reason that we can do that is the subtraction property. We just subtracted those two angles. Now at this point, again, I have my transversal here, and we can see that we're creating these angles. So this time, line QR and line PS could be our parallel lines, with line QS being our transversal once again. So what's the relationship between angle 3 and angle 4? Well, they're also alternate interior angles. And if alternate interior angles are congruent, which angle 3 and angle 4 are, then line QR is parallel to line PS. So we can go ahead and put that now. Line QR is parallel to line PS. And that's the same as 3. So for number 5, we can just put same as 3. Because again, if alternate interior angles are congruent, that implies that the lines are parallel. And I can go ahead and draw my parallel marks on there now. The last thing that we have is number 6. PQRS is a parallelogram. Is a parallelogram. I'll just write it underneath. And the reason that we can say that is if opposite sides of a four-sided figure or a quadrilateral are parallel, then the quadrilateral is a parallelogram. So let me go ahead and just write this up top. This is reason number 6. If opposite sides of a quadrilateral, and I'll just put quad here, are parallel, then the quadrilateral is a parallelogram. And with that, our proof is now complete. So again, you guys are going to be using these angle relationships to prove parallelograms, prove trapezoids down the road. This will be very useful, especially as we start classifying these things later on. So keep that in mind. All right, next up, I'll go ahead and let you guys try out this next one on your own. Whenever you're ready, you can go ahead and move on, and we'll check our work. They tell us a trapezoid is a four-sided figure with exactly one pair of parallel sides. Given that angle 1 is supplementary to angle 3, and angle 2 is congruent to angle 3, prove that TRAP is a trapezoid. So first off, we're going to start with our given statements. So number 1, angle 1 is supplementary to angle 3. That's given. We also know that angle 2 is congruent to angle 3. That's also given. So I can actually draw this one up. Angle 2 and angle 3 are congruent. From here, I can say that angle 1 plus angle 3 equals 180 degrees. So for number 3, angle 1 plus angle 3 equals 180 degrees, because that's the definition of supplementary. If two angles are supplementary, then they add, their sum is 180 degrees. So I now know angle 1 plus angle 3 is equal to 180, but angle 2 and angle 3 are congruent. So would I be able to replace angle 3 with angle 2? Well, yes. So let's go ahead and do that. We now have, for number 4, angle 1 plus angle 2 is equal to 180 degrees. And all we did here was substitution. Next up, if that's the case, if they add to be 180 degrees, then I can say that they are supplementary angles. So for number 5, I can say angle 1 is supplementary to angle 2. My reasoning for that, if two angles add to be 180, they are supplementary. Two angles add to 180 degrees, they are supplementary. So I now know that these two angles will add to be 180. What is their relationship? Well, looking at these two angles, if RT is my transversal line, RA and TP could potentially be our parallel lines. Well, these are on the same side of our transversal and they're inside our parallel lines. So they're same side interior angles. And we know same side interior angles are supplementary. So therefore, we can say that line RA is parallel to line TP. RA is parallel to line TP because same side interior angles that are supplementary implies RA is parallel to TP, implies parallel lines. Finally, we can say that TRAP is a trapezoid because if a quadrilateral has one pair of parallel sides, then that is a trapezoid. So let me go ahead and just put that up here. So TRAP has 4 sides and only one pair of parallel sides, therefore it is a trapezoid. And that is our proof. So TRAP has 4 sides, 1, 2, 3, 4, and exactly one pair of parallel sides, meaning RA and TP. Therefore, it is a trapezoid. All right, so that is our 2 proofs to get started today. We got one more later on. But next up, let's go ahead and focus in on some other types of problems. So here is a problem from set C. Here we go. Show that the quadrilateral formed by joining consecutive midpoints of RECT is a parallelogram. So what I want to prove is that this figure inside, this dashed figure, is a parallelogram. So to do that, I first need to find the midpoints. Now I have point R at 0, 0 and point C at 12, 4. Now if this is a rectangle, which it's telling me it is, then these should be straight lines here, and they should go right along with our grid. So point T should be the point 12, 0. Point E should be 0, 4, which makes it very easy for us to find these midpoints. This midpoint should be 12, 2, halfway up, right? This midpoint should be 6, 4. This midpoint down here is 6, 0. This midpoint to the side is 0, 2. So we now have all of our midpoints. Now, at this point, we're going to go ahead. So again, step 1, find each of the midpoints. Step 2, we're going to find the slope of each of these now. So I went ahead and called it A, B, D, F. I couldn't use C or E because, again, they're already used. So we went ahead and made this new parallelogram, or at least what we're trying to find, and we're going to find the slope of a couple of these lines. So the first slope that I'm going to find is the slope of AF and the slope of BD. So to do that, we use y2 minus y1 over x2 minus x1. We find out that both AF and BD have the same slope of 1/3, which means that they're parallel. If 2 lines have the same slope, they are parallel. Next, we do the same thing with lines AB and FD, and we find out that those lines are also parallel. Sorry, it kicked me out. 1 sec. All right, so we find out that they are also parallel. They both have a slope of -1/3. Well, if both of these are parallel, the blue lines and the red lines, well, then it's a parallelogram. So I have 2 pairs of parallel sides, which by definition is a parallelogram. Opposite sides are parallel. All right. Moving on, we have this next proof. So go ahead and try this one out on your own, and then I'll be explaining it as we go. So given that angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 2, we want to prove that ABCD is a parallelogram. Now again, a parallelogram has opposite sides that are parallel. That's what we're trying to prove here. So we start off with our given information that angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary. At this point, I'm going to go ahead and I'm going to focus in on angles 1 and angle 2. So looking at this, line segment AB would be our transversal, and we're trying to prove that BC and AD are parallel right now. So what's the relationship between angle 1 and angle 2? Well, these two angles are on the same side of our transversal, and they're also inside our parallel line, so they're same side interior angles. And I know that angle 1 is supplementary to angle 2. Well, we also know same side interior angles need to be supplementary. And if they are, that would imply that line BC and line AD are parallel. Because if same side interior angles are supplementary, that implies parallel lines. I can do the same thing with angle 2 and angle 3. This time AD is my transversal, and I'm trying to prove that AB and CD are parallel. So what's the relationship between 2 and 3? Well, again, same side of my transversal. Inside the parallel lines, they're same side interior angles, and we know that they're supplementary. So therefore, lines AB and line DC are parallel lines as well, because if same side interior angles are supplementary, that implies parallel lines. Same exact thing as the one right above it. From here, we see that we have two sets of opposite sides being parallel, so we can go ahead and say that ABCD is a parallelogram, because if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. Don't forget, guys, your angles will always lie on the transversal line. So when we were going through this, we can see that both of these angles lie on the transversal, and same for the one before it. These both lie on the transversal. So that will always be the case when you're making these. You'll have the parallel line and the transversal that create the angles that you're looking at. So just keep that in mind as you practice these. All right, so with that, we are finished for today. If you guys have any questions, please let me know.